Hi, my name is Ethan Parker. Welcome to the Technology Skill Hub Beginners course on machine learning. This course is not meant to be boring, but it is about technology. Cool technology. Machine learning is a crucial component of artificial intelligence, AI, that is shaping our future in various fields. As we go through this lecture, we will break down our discussion into a few key sections. An overview of machine learning and its significance. The fundamental differences between traditional programming and machine learning. The primary types of machine learning, which are supervised, unsupervised, and reinforcement learning. Machine learning is everywhere around us, from the suggestions we get on Netflix and Amazon to advanced technologies like self-driving cars. By the end of this lecture, you should have a solid understanding of what machine learning is, how it operates, and the different approaches taken in developing machine learning models. So let's get started with our first section. An overview of machine learning. So what is machine learning? Machine learning can be defined as a subset of artificial intelligence that focuses on the development of algorithms that enable computers to learn from data. The core idea of machine learning is that it empowers systems to make predictions or decisions without being explicitly programmed for each specific task. Instead of following fixed rules, machine learning algorithms utilize data to identify patterns and structure, learning and improving iteratively. Why is this important? The importance of machine learning lies in its ability to process large amounts of data and derive insights at a pace that would be impossible for humans. In our data-driven world, organizations are generating enormous amounts of data every day. Machine learning enables businesses, scientists, and researchers to analyze this data and gain meaningful insights, turning data into actionable intelligence. For example, in healthcare, machine learning algorithms can analyze medical images to aid in early diagnosis, enhance the accuracy of patient data analysis, and even predict potential outbreaks based on historical data. In finance, machine learning models are used to detect fraudulent transactions in real time by analyzing patterns of behavior and flagging unusual activities. These applications showcase the scope and potential of machine learning as a transformative technology. And how does machine learning work? At its core, machine learning involves several key components. First, the foundation of machine learning is data. It includes input data, which can take various forms such as images, text, numbers, and more. Quality and quantity of data critically impact the performance of machine learning models. Next, algorithms are the mathematical models that process the data. They identify patterns and relationships within the dataset to make predictions or decisions. Next, training. In the training phase, the algorithm learns from the provided data by adjusting its parameters to minimize errors in its predictions. The model learns by iteratively refining its predictions based on the actual outcomes. Finally, evaluation. After training, the model's performance is evaluated using a separate test dataset to assess how well it generalizes to new, unseen data. Let's consider a simple scenario to clarify these concepts. Imagine we want to build a model that predicts housing prices based on features such as size, location, and number of bedrooms. We would start by gathering a dataset with historical data on those house sales, including their prices and attributes. The model would then be trained using this data, learning how different factors influence the price. Once the model is trained, we can input new house features, and it will predict the price based on the patterns it learned during training. The ability to create such predictive models is what makes machine learning so powerful across numerous applications. So what are the differences between traditional programming and machine learning? Traditional programming follows a straightforward approach where a programmer writes explicit instructions detailing how to solve a particular problem. The programmer defines clear rules and logic that the computer executes step by step. For example, consider a simple task like sorting a list of numbers. In traditional programming, a developer would implement a specific sorting algorithm, such as bubble sort or quick sort, by writing code that dictates each step in the process. But there are limitations of traditional programming. While traditional programming can be effective for straightforward tasks, it faces limitations when dealing with complex, real-world problems, particularly those that involve significant variability and uncertainty. In such cases, it requires considerable effort to account for all the possible scenarios. Moreover, traditional programming is less adaptable. Adding new functionalities or adjusting to new data patterns might require extensive rewrites of the code. In contrast, machine learning operates on a fundamentally different principle. Instead of relying on predefined rules, machine learning algorithms learn directly from data. This represents a significant paradigm shift in how computers are used to solve problems. With machine learning, the programmer provides data instead of hard-coded rules, and the algorithm figures out the best approach to accomplish the task. This adaptability is crucial when dealing with complex scenarios like recognizing images, understanding human language, or predicting stock market trends, where traditional programming might struggle. Let's review the key differences. 1. In traditional programming, the programmer specifies every rule and logic. In machine learning, the algorithm learns from data and can adapt its functionality. 2. Flexibility. Machine learning models can generalize from the training data to make predictions or decisions on new, unseen data. Traditional programming would require extensive modification of code to adapt to new requirements. 3. Handling complexity. Machine learning is effective for complex tasks involving large datasets and variability, such as facial recognition or natural language processing, enabling the creation of intelligent systems. Let's set up an example to illustrate the differences in a practical context. Let's talk spam email filtering. In traditional programming, a programmer might define a set of rules, specifying which keywords indicate spam, e.g. free, win, discount, along with other criteria. However, creating an effective spam filter using this approach would require a lot of manual effort and may still fall short against sophisticated spam techniques. Using machine learning, instead of defining rules, we can train a model on a dataset of emails labeled as spam or not spam. The model analyzes the text patterns, learns the nuances, and ultimately learns to identify spam emails based on the data it has seen, making it more effective at filtering out new spam. Make sense? So what are the different types of machine learning? You see, machine learning can be broadly categorized into three main types: supervised learning, unsupervised learning, and reinforcement learning. Each type serves different purposes and is suitable for distinct kinds of tasks. Understanding these categories is fundamental as you start your journey into machine learning. Let's start with supervised learning. Supervised learning involves training a model on a labeled dataset, where each input data point is paired with the corresponding correct output. The goal is for the model to learn the mapping from inputs to outputs. Supervised learning is extensively used for problems such as classification, classifying data points into predefined categories. For example, email classification, spam versus not spam, or image classification, identifying objects in an image. It is also used for regression, predicting continuous outcomes based on input variables, like predicting prices of houses or stock values based on various features. That is supervised learning. Let us now consider unsupervised learning. In unsupervised learning, the model is trained on data without any labels. The algorithm seeks to identify patterns and relationships in the data independently. Unsupervised learning is often used for clustering, which is grouping similar data points together. For example, customer segmentation for marketing to identify different customer groups based on purchasing behavior. It is also used for dimensionality reduction, which is reducing the number of features in a dataset while preserving important information for tasks like visualization or noise reduction. To illustrate unsupervised learning, consider a retailer analyzing customer data without predefined labels. The model can group customers into distinct clusters based on similarities in their purchasing behavior, allowing the retailer to tailor marketing strategies to each segment. That is unsupervised learning. Finally, let's look at reinforcement learning. Reinforcement learning is inspired by behavioral psychology. In this type of learning, an agent interacts with an environment, learning to take actions to maximize cumulative rewards. The agent learns from feedback in the form of rewards or penalties. Reinforcement learning is commonly used in areas like gaming. It teaches AIs to play games like chess, Go, or video games by exploring different strategies and optimizing their gameplay. It is also used in robotics, enabling robots to learn how to perform tasks through trial and error. Also, how about self-driving cars by allowing vehicles to interact with their environment and learn safe navigation strategies? Consider training a robot to navigate a maze. Through reinforcement learning, the robot explores the maze, receiving positive feedback, rewards for reaching the goal, and negative feedback, penalties for hitting walls. Over time, the robot learns the best path to take through the maze based on this feedback. That is reinforcement learning. These three types of machine learning encompass a wide array of applications and techniques, each relevant to different problem domains. Understanding these distinctions helps lay a foundation for further exploration into machine learning methods, models, and implementations. As we conclude this introduction to machine learning, I hope you have gained valuable insights into what machine learning is, how it differs from traditional programming, and the various types of machine learning techniques. To summarize, machine learning refers to the development of algorithms that enable computers to learn from data, effectively allowing systems to adapt and make predictions without explicit programming. The stark contrast between traditional programming and machine learning lies in the learning mechanism, flexibility and complexity handling, areas where machine learning excels. Finally, we've discussed the three core types of machine learning: supervised, unsupervised, and reinforcement learning, each with unique applications and approaches to solving problems. In our upcoming lectures, we will delve deeper into specific topics, algorithms, and tools used in machine learning. This journey will equip you with the skills and knowledge necessary to leverage machine learning in real-world applications. Cheers and have a blessed day. Please like and subscribe for the sake of Tech Skill Hub and all sane people on the planet. This is Ethan signing off.